He was to solve the inequalities below and express the solutions in both interval and inequality notation. So to start this off here, I'm going to go ahead and set each of these pieces equal to 0, because basically what I'm going to do here is I know that this is a cubic function if I were to kind of graph this side of the equation here. And I'm trying to see when it's greater than 0. So if I have a cubic function, I'm looking at one of the y values greater than 0. And so I'm just going to look at, where that happens. So when is it the x values between those functions or those points there? So I really am just going to start by graphing this and finding the x-intercepts. So first thing here, this is really negative x plus 1 equals 0. I'm going to subtract 1 from both sides and get negative x equals negative 1. So I have my first intercept at positive 1. Then this one gives me positive 3. And this one gives me positive 5. So when I graph this, 1, 3, and 5 are my intercepts. And again, like the exact graph doesn't necessarily matter on this one, because what I know here is that since it's a positive third degree polynomial, it's going to be going up at the end here. So I have this general sketch. I see that these values right here, I should probably highlight this instead of marking it, but these values right here are when it is positive or greater than 0. And so really I'm going to look at these x values right here, and it's between these first two, meaning the way I would write this is that our x values are between positive 1 and 3, or the x values that are greater than 5, because that shows me that right piece there. That's inequality notation. Interval notation would be between 1 and 3, and since it's just this greater than symbol, that is why I am just using parentheses or less thans. And then the or, I use this union symbol, and then I say from 5 to infinity. So here's my actual answers. These are the x values where it creates a number that is greater than 0, between 1 and 3, and greater than 5. Second one, same idea here. First thing I'm going to do is I'm going to factor this, and I'm going to try and, again, just graph it really is going to help me, or a real sketch of the graph here. So negative 5x and 3x. Throw it in the box here, x squared, negative 15, negative 5x, 3x, 3. Okay, so now I'm turning all of this here into x plus 3 times x minus 5. And when is that less than 0? So on the graph here, it is a parabola, or x squared. So I have my intercepts at negative 3 and 5. So 1, 2, 3. 1, 2, 3, 4, 5. And again, it's going to be something like this. And I'm looking for when it's less than 0. So I'm looking at these values here. So it's between negative 3 and positive 5. So the way I would write that is negative 3 is less than x, which is less than 5. And in interval notation, I would say between negative 3 and positive 5. And those are the x values that make this equation less than 0.